So we have a 200 kg mass, so basically 2000 Newton. Weight is resting on a rough inclined plane at 30 degree. The coefficient of friction is 1 by root 3. Find the least and the greatest force acting on parallel to the plane to keep the mass in equilibrium. So my question to you guys is, where is this least and the greatest force comes into picture? Well, this is a bit weird scenario. So it would be better if you guys are able to pause over this. Just think about where is this least and the greatest force that they are talking about. Okay, one condition is that it's parallel to the plane. So forces are parallel to the plane. It's like this. It's parallel to the slope. See, it's quite simple. It either has to be, okay, I'll ask you guys this way. I can either pull the object down or push the object up. What should I be doing? I mean, in which case it will be least, and in which case it is the greatest force. The least force will be when you pull it down, because the already mass is there. A bit of push, if a bit of pull, it'll start sliding down. For me to push it up, right, this has to be maximum. It's not only that I'm pulling against friction, also I'm pulling the weight. Okay, and so this will be the maximum scenario. That should be commonsensical to you guys. Now, first thing first, let's resolve this weight parallel and perpendicular to the surface. So this is 30 degree. I'm not writing that. So this will be cos 30, which is root 3 by 2. And this is divided by 2. These are all the forces that we are looking at. Now, let's see case of, we'll start with least value, least force. So for this, let me draw a free body diagram. So we have the normal force, which has to be 1000 root 3, and we have 1000 Newton. Along with this, we are trying to pull the object in this way with some force F, right? And of course, because of which we have your friction to the right. So this is down the slope and this is up or perpendicular slope. This is a scenario. So let F, we'll call this as D or least, or F1 at least. F1 be the force pulling the object down. Now applying Newton's second law along the slope. What we have here is I is equal to M into A. So we have 1000 plus F should be resisted by Fs max, and this has to be 0 because the object has to be at rest. So a bit of rearrangement, your force will be 1000 minus Fs max is 1 by root 3 times the normal force, which is root 3. Okay, so I have to write the formula. So you can write the formula here. So this and this gets cancelled, and this is 0 Newton. You guys agree? This has to be 0, and 1000 minus 1000 means what? There's no least force, or you can't apply your force. That's the scenario. So we can't apply any force pulling the object down. It's just there, exactly there. A bit more up, even a degree angle, it'll start sliding. Right? Now let's look at the case of maximum force. So when we have the force to be maximum, it would be a scenario wherein this is already there, the mass will not change because of the mass, and we have the normal force will not change, 1000 root 3 Newton. Now we are trying to pull it up with a force F, and the friction will act in the opposite direction, Fs max. Right? So I think I didn't miss anything. 1000 and so on and so forth. So I can do this as positive. This can be F2. Let F2 be the maximum force applied on block. Then we are applying Newton's second law along the slope. And what we have here is 1000 minus then the static friction plus F2 should be equal to 0. And so F2 is 2000 Newton. Right? That's it. So that's your answer. So you can write the statement at the end. So that would be the least and the maximum force that we can apply.